Hi guys, welcome back to the channel. In this video we are going to discuss the concept of encoders. So let's get started. So this is the main basic preview of the encoders. In the previous videos, majority of the videos we have discussed the decoders. So in the decoders we have said that we are getting or we are giving n inputs, and in our outputs we are getting 2 power n outputs. But same in the encoders it is vice versa. So we are giving 2 power n inputs and we are getting n outputs. So the vice versa of decoders. So it is known as encoders. If you see 4 cos 2 encoder, you can see that there are 2 power 2, that is 4 inputs and 2 outputs. So that is D0, D1, D2, D3 as inputs, A, B as outputs. In that decoders we are going to pass 2 inputs. According to the inputs, output will be selected. But here we are going to pass out of 4. In this case, out of 4 we are going to pass one input in only one thing, that is whether in D0, whether in D1, or whether in D2, or whether in D3. But you are going to obtain output in all the things, that is you will get output in A and you will get output in B at a time. Let's quickly see the truth table for the 4 cross 2 encoder. So if you observe, there are total 4 inputs. So according to that I have drawn the truth table. If you observe D1, D2, D3 and AB as the truth table, if you observe. So according to I said, if we are going to pass only in the one of the variable input, that in the D0 first, in the D1 second, and the D2 next, and D3 next. So if you observe in the first case, if you pass D0, means the only thing D0 is selected, or we are passing only input in D0, then we are going to get output. So as D0 is corresponding to 0 0, we are going to have AB as 0 0. If incoming input is present in D3, the corresponding D3 means 1 1. So as we also, it is just opposite of the decoder. This is the overview of 4 cross 2 encoder, all four possible combinations that you can see over there. If you are passing input in D0, you are going to get output as 0 0. If you are passing input in D1, you are going to get output as 0 1. That is basically in binary. If you convert to decimal, that is 1. So next, if you are going to pass input in D2, output would be 1 0, that is 2. If you are passing input in D3, output would be 1 1, that is 3. So same will be applied in the 8 cross 3 encoder as well. So we already know A and B are the outputs, not the inputs. For everything we need to have the output circuit diagram. So in this situation also, for 4 cross 2 encoder, we are going to draw the circuit diagram for A and B. So if you observe A, we have minterm at second position and third position. So the second position corresponding to D2 and third position corresponding to D3. So the sum of both of them is the final output of expression of A. In the same way, if you observe for the B output expression, so there are minterms in the first position and third position. So corresponding to that is D1 and D3. So sum of both of them will give the output expression for B. So D1 plus D3 is output expression of B. So we need to construct the circuit diagram for A and B. So let's see how to do that. This is the simple way of constructing the circuit diagram of A and B. So if you observe the output expression of A, that is D2 plus D3, and output expression for B, D1 plus D3. So for this purpose we are having the 4 variables, but in this situation D0 is not used. If you observe the truth table also very clearly, in the truth table also we did not use or include the D0. So because it's a format, so we have only just output expressions is obtained as D2 plus D3 for A. So we are going to join the D2 line, and the second OR expression for the B also we are having D3 common. So I took D3 common and D1 for the separate the second one. So I hope you know how to draw the circuit diagram. So this is the 4 cross 2 encoder circuit diagram. So next thing in the encoders is 8 cross 3 encoder. So as the same thing, 2 power 3 means 8, then you are going to have the 3 as n outputs. So if you observe, I have already drawn the truth table also. So again same thing, we are going to have from D0 to D7 means total 8 terms, and ABC as output, as same like but inverse of decoders. For this also we are going to have the output expressions or the circuit diagram for A, B, C. So for that we need to trace out the minterms. So if you observe that clearly, we have for A in the positions of M4, M5, M6 and M7. So that is correspondingly here in this case we have that is the D4, D5, D6, D7. So sum of all of them gives the output expression for A. In the same way, we can get the output expression for B also. So if you observe D2, the one is corresponding, the first box of 1 under B corresponding to D2, then next box is corresponding to D3, then next D6 and D7. So sum of will give the output expression for B. In the same fashion, obtain the output expression for C also, that is D1 plus D3 plus D5 plus D7. So as this is the 8x3 encoder, so we are going to have total 3 variables only, that is A, B, C. So we have already in the truth table also. So according to that, so as we are obtaining the 3 outputs, means 3 in binary, that is A, B, C, we are going to pass total 8 inputs, that is from D0 to D7. So I draw 7 input lines, that is from D0 to D7, all are variable input lines. So if you observe the A expression, that is D4 plus D5 plus D6 plus D7, so according to that connect to, so there are total 4 terms, so connected to 4 variable lines. So that is, I hope you are understanding. So in the same fashion, connect to B, so connect all lines to C to the input lines as well. So if you observe one thing clearly, in this we are not using D0 at all. So this is also a quite simple thing that we can understand from the truth table as well. So D0 is not used in this also. If you know decoders, it is very fast and quick to understand these concepts. So let's also quickly see the applications of the encoders. So the first application in encoders is the code conversion. In the code conversion part, we have the conversion of from decimal to binary. So I hope you know what is meant by decimal. Decimal means normal, nothing, from 0 to 9. The total, we have total 10 decimal numbers, the normal numbers that we are using in daily life. So that is, if you represent in a normal variable notation, that is can be represented as from D0 to D9. So in binary also we can represent from 0000 to 1001. So this conversion can be performed with the help of the 16x4 encoder. So let's see how to convert that. So if you see quickly the position of under A in the binary format, that is highlighted in the circle also, you can observe there. So the last A positions, if you can see, that is in the positions of D8 and D9. So the output expression for A is D8 plus D9. So if you want output expression for B, so consider the ABCD variables. If you consider come straight down in the B column, if you observe, there are correspondingly D4, D5, D6, D7. I have highlighted in purple way also. So there I have highlighted ones also. So those are the ones the corresponding to D4, D5, D6, D7. So this is our final output expression for B, because the 1 is corresponding to that min term. So that is why that is our output of B. Remaining all are zeros. So we will not consider min terms in zeros. We will only consider min terms for ones. So in the same fashion, you can also find the output expressions for C and D. So C corresponding C down column, you need to find ones, and you need to correspondingly find the min terms, that is D2, D3, D6, D7. So in the same fashion, find for D also output expression, add up all of them. So as you all find 8x3 encoder, in the same fashion we also need to construct the circuit diagram for the decimal to binary as well. So if you observe there, we are not going to construct all six. This is actually the 16x4 encoder, but here we need not to draw all the 16 input lines, because so we need just the 10 lines, that's it. That is from D0 to D9, that is we can say simply. So binary is, we can simply say that is in the format of total we are going as A, B, C, D as outputs. So from this we can say this is a simple decimal to binary conversion, because in binary we are sending, suppose if you send or if you select the first, the D1 line, suppose, so D1 means what, that is 0 0 0 1. So A, B, C, D would be zeros and D would be 1. So that is the simple conversion from decimal to binary. So if you select the line number 6, suppose 6 line, so what is 6 in binary? So that is 0 1 1 0. So 0 A is 0, 1 1, that is B and C would be 1 and 1, and D would be again 0. So that is the simple representation, that is simple conversion I can say. So we have some drawbacks for the encoders, normal encoders. So this is the normal encoder, that is 8x3 encoder. So the drawback I will say first, but let's observe. So if you select the D0 line, so in the truth table also you can observe there, if you select the D0 line, only one output is selected, that is ABC, that is 0. So there is no problem with this. But the problem arises when there is 2 inputs at a time. If you observe, I am sending 2 active lines, that is I am active in D0, I am active in D7. then what output would be selected? That is the correspondingly 0 0 0 will be output, that is D0 will be selected, or ABC would be D7, that is 1 1 1, which is our output. If you observe in the truth table also clearly, so at a time I am selecting, or at a time I am passing two ones in that same line, so it will be selected D0 or D7. So that is the confusion in the normal encoder. But there is another encoder called Priority Encoder. So this says what means, if you are sending more than one inputs, the largest input or the more priority or the biggest one will be selected as our final output. If you consider reject D0, accept D7 because it is bigger, so our output would be D means 111, not ABC would be 111, not 000 in this case. So this is the main thing we can rectify with the priority encoder. So this is a separate concept though, so this will be discussed in the further video, upcoming video. So see this example also. Not only that, if you have more than two inputs, suppose if you observe, if you have three inputs in the same line, like in the line of 5 means the M term M5, that I can say, we have active in the D1, we have active in the D5, we have active in the D7. Actually the active only should be in the D5, but we have another two actives, so which one should be selected? So you might think so according to this, so D5 is the main thing of the line it belongs to, so we should select D5, not like that. So which one is highest here? So D7 is highest, so D7 will be selected like that. If D7 is not there, only D1 and D5, so D5 is the highest, so D5 will be selected. So you can observe that clearly D7 is the highest, so it is selected. So remaining two inputs will be rejected, means the final output A, B, C would be 1 1 1. And more about priority encoder in the upcoming video. So I hope you understood this. Thanks for watching up to now.